In this video, we're going to be going over one method we have for detecting potential outliers based entirely off the z-score. And if you recall from a previous video, the z-score, or z, is equal to the data point that we're interested in, so x, minus the sample mean for that data set, so minus x bar, divided by the sample standard deviation, so divided by s. And recall that the z-score is just simply telling us the number of standard deviations away from the mean that the particular data point we're interested in falls. And the formulas for those two values, so the formula for x bar is equal to the sum of each xi value as I goes from 1 up to n, and then we just divide that sum by the total number of data points we have, or n. And the sample standard deviation, or s, is equal to a sum for each of our data points, so xi, minus the sample mean, so minus x bar, and that value squared for I up from 1 up to n, and then we divide that whole mean by n minus 1. So now that we recall what the formula for the z-score is, we need to have some ranges for those z values to determine if something is a suspect outlier or not. And we're going to have two different designations for suspect outlier. We're going to consider something a suspect outlier if the absolute value of the z-score, so the absolute value of z, is greater than 2. And we're going to consider something a highly suspect outlier if the absolute value of z is greater than 3. So we're going to use these two ranges of values to help us determine if something is a suspect outlier or not. Now to do that, we're going to need a data set to practice on. So we're going to use this data set here of 20 male university students and the weekday exercise time in minutes that each of those participated in. So we just need to calculate first the sample mean for that data. So our x bar is going to be equal to the sum of all those data points divided by n. And if we actually went through and calculated that, we would calculate the sample mean to be 47.6. And we need the sample standard deviation. And if we went and actually calculated that, we would get a value of 58.1. So now we can just simply walk through and calculate the z-score for each of our different sample points and determine if they're suspect, highly suspect, or not an outlier. But we can kind of cheat in how much work that we're going to actually need to do by simply looking at first the most extreme data points in our data set and working our way in if those data points turn out to be suspect or highly suspect outliers. And then once we get to a point that's not considered a suspect outlier anymore, we can stop and no longer need to calculate the z-scores for the remaining data. So to start that out, we're just going to start with our lowest data point, or 0.0. So we're going to say that z is equal to 0.0 minus our sample mean, so minus 47.6, divided by the sample standard deviation of 58.1, and we get a negative 47.6 divided by 58.1, which gives us a value for the z-score of negative 0.819. So we see that this value does not fall in the range of suspect outlier or highly suspect outlier because the absolute value of this is just 0.8, which is not anywhere near that 2 cutoff that we need for a suspect outlier. So now that we've determined that we don't have any suspect outliers on the low end of our data, let's check the high end of our data and see if we have any suspect outliers there. So to do that, we're just going to start with our most extreme high end value of 199.5. So we're going to say that z is equal to 199.5 minus our sample mean of 47.6 divided by our sample standard deviation of 58.1. So if we actually do that subtraction, we get 151.9 divided by 58.1. And doing that division gives us a z-score of 2.614. So with a z-score of 2.614, we see that 199.5 is greater than 2 for a z-score, but less than 3, which means that 199.5 is a suspect outlier. So since 199.5 is a suspect outlier, we just keep working our way lower and lower in our data set, checking those subsequent values until we find something that isn't a suspect outlier. So to keep going, we're just going to check our 151.5. So we have z is equal to 151.5 minus our same 47.6 and divided by our sample standard deviation of 58.1. So if we actually do that subtraction, we get 103.9 divided by our 58.1, which with the division gives us 1.788. So we see that our 151.5 is not a suspect outlier because it has a z-score of less than 2 with 1.788. So at this point, we can actually stop testing all of our data because we've found the most extreme data points, checked them to see if they were outliers, and worked our way in until we got to a stopping point where we no longer had any suspect outliers.